Okay, so some logs. We're going to find the value. Okay, if I do something like that, okay, so in other words, if I change this to exponential form, it's 2 to exponent what will give me 1/8. Well, remember, hopefully you know this, this is -3. Okay, because 2 to the -3 is 1 over 2 to the +3, which will give you that 1/8, okay? Do remember, you're going to get negative answers, okay, when you log these fractions, okay? So that's -3. Okay, the next one. Well, this is just 10 to the 4. Okay, this is actually log base 10, because remember, it's base 10. When it doesn't say it, it's base 10. And that is just the answer of 4. Okay. Right. Next. Okay, so the first part of this, on the left-hand side, I'm going to combine to a single log. Because it's a plus, it becomes a multiplication. This is log to base 3 of x minus 8 times x equals 2. I just multiplied those two together because it's a plus. So here it is as a single log. Let's do the distributive law. That's x squared minus 8x. Okay. Right, like previously, like up here, I'm going to change from log to exponential. 3 with an exponent of 2 equals x squared minus 8x. That's 9. Okay, so I'll take away 9 from both sides. And that's what I get. Okay, so let's erase some stuff up here. Now then, hopefully things like this factor. Parenthesis. Two numbers, -9 when you multiply, -8 when you add, is -9, +1. Okay, so x equals 9, x equals -1. Now then, just don't forget to check. This will not work because if you put it back in, you cannot log negatives. So that's the only answer. Okay. Okay, next one. Okay, we need to get this by itself. So let's get rid of this 8 by multiplying both sides by it. That's 16. Okay. Now take away the 5. Okay, there we go. Take away 5 on both sides. Now, remember this, log both sides. Log both sides. The reason is that can come to the front. I have x log 12 equals log 11. So divide both sides by log 12. And basically, that's your answer. X equals log 11 over log 12. And that's okay. You don't have to put it on your calculator. Okay. Right, last one. Now, this is definitely log both sides, but it's a lot more work. Let's take a look at this one. Right, if I log both sides, okay, in other words, log of 3 to the x plus 1 equals log of 2 to the 2x. Okay, remember, I can bring these to the front. Bring these to the front. So x plus 1 times log 3 equals 2x times log 2. Right, now then, you can, if you want to, do the distributive law with this, but I would just say, remember, if you want to, these are actual numbers. So, the log of 3, calculator time. Okay, 3 log equals, right. This is 0.477 with the x plus 1. That's what log 3 is. Let's take a look at log 2. This is 0.301 with the 2x. Okay. Now you can then do the distributive if you want to. Here we go. 0.477x plus 0.477. That's just me doing the distributive law. Equals, what's 2 times 0.301? That's 0.602x. So I think I'll take away this from both sides. So 0.602x, take away 0.477x is 0.125x, and that equals 0.477, that's still here. Divide both sides by 0.125. So 0.477 divided by 0.125 equals 3.816. Right. Or thereabouts. There you go. Okay, let's keep on going. Now then, do these equal each other? Well, log to base 4 of 64 is 3, because 4 to the power 3 will give you 64. Log to base 2 of 8 is also 3, because 2 to the power 3 will give you 8. So it's true, okay? True. Now, domains. Remember, anything you log must be greater than 0. See that? You can't equal 0. Anything you log must be greater than 0. If you add 1 to both sides, which that's what it is. That is in interval notation. So that's okay. Let's keep on going. Horizontal asymptote of this. Right, so we have, let's take a look at this one then. This is, if I just do 3 to the x, remember all exponentials look like that. They always pass through what? 0, 1, the y-intercept, because anything to the power 0 is 1. If I move it up 2, then this original horizontal asymptote of y equals 0 will become y equals 2 if I move it up 2. So it's positive 2, not negative 2. That's false. And the bottom one here. Now an oblique. Okay, right. X plus 2 oblique. Now then, to do oblique or slant asymptotes, you literally do have to do a division. In other words, okay, x minus 1, no idea what I wrote there, into x squared plus x. Or if you like synthetic division, you are doing 1, and then with a 1x squared, a 1x, and no number at the end. So I'm going to do it by synthetic division. 1 times 1 is 1. Add those two together, you get 2. So in other words, this is x plus 2. Remember, if I divide an x squared by an x, I'm going to be left with an x. So by synthetic division, I actually do get that. Okay, so that is